to our webinar, A Streamlined Toolset, Optimizing Kubernetes Costs and Developer Productivity. Today we have speakers Jesse Goodier from Kubecost and Ben Potter from Coder. And just to give you a heads up, we'll also be recording this session. So if you cannot attend the whole thing or want to share it with others, we will be sending out an email with the recording after the webinar is over. And with that, I'll go ahead and kick it off over to our speakers.
Thanks, Dee. So yeah, my name is Jesse Goodier. I'm at Kubecost. We're a startup, so I wear a number of hats, including working with our integration partners like Coder. So we'll have a relatively technical presentation here with demos. So hopefully that makes it interesting for most of you. Just a quick background, we'll have an overview of Kubecost for those that are unfamiliar with it. We'll have an overview of Coder for those of you unfamiliar with Coder. And then we'll get it right into our demo, and we'll have time at the end for Q&A. And we have quite a few questions already submitted, so thank you for that. But as we go along, Ben and I are very happy to jump into relevant context questions. So if you've got something that's relevant to what we're currently talking about, please let us know. With that, I'll kick it over to Ben.
Hey, yeah, happy to be here. I'm Ben. I work at another startup, so I wear several hats. My title is product management, but I also love working on partner integrations and demos. Jesse, did you want to start by giving like a brief kind of overview of Kubecost?
Yep. Yeah. Sorry. So I forgot the next slide was. Yeah, Kubecost. We've been around for a while, even though we're considered a startup, Series A. We've got a number of very large customers where you see the logos on the screen. As Kubernetes becomes, more and more significant part of the cloud spend, Kubecost becomes the de facto solution for helping understand where those costs are going and give recommendations on how to reduce those costs. We'll get into a demo of the tool in a little bit, but we work on all of the major cloud platforms. We've got integrations coming with even Oracle. My wife works there, so I'll give her a plug. But we also work with very secure, three-letter government agencies because we have the ability to work in a completely air-gapped configuration. And then, I would say, the majority, probably 75% plus, are running on one of the big three cloud providers. Go to the next one.
Yeah, and this is an opportunity to introduce Coder. Unfortunately, I don't have as many boxes, but Coder is an open source, self-hosted platform for cloud developer environments. So by nature of being open source and self-hosted, we have many large enterprise customers as well, the three-letter agencies, and we support air-gapped and offline. But really where we see people starting with their Coder deployments is in the three major clouds as well. Now, what is a cloud developer environment? The main premise is, if you think back to the last time you had to set up a project, if you were a software engineer, you had to do a manual steps, probably between 10 and 30 steps on your computer to get things set up. You had to mock data to run your services. And essentially that's all automated away with Coder with a cloud IDE instead, with all of the tools pre-installed. So in terms of what this workflow actually looks like, there's two workflows actually. So the Coder admin will create templates for various use cases, whether it's data science or software development. If it's a monorepo or a single service, that's all written as a Terraform template. The developers themselves don't have to write any Terraform. They go into the Coder user interface and provision a workspace. So here there's a create workspace form where the developer can choose the CPU, the disk, and what language they want to use, and then get a workspace in. Now, the actual workflow here is then the developer clicks this VS Code button and gets into their editor. So they're still able to use their local editors if they want to. We also provide an entirely web-based version, but the actual workspace themselves is running as a cloud workload somewhere. The problem that we've run into with many of our customers is running these cloud environments are pretty expensive. A CDE, or we like to call it a workspace in Coder, is essentially a Kubernetes pod and a disk. And CDEs are the most beneficial for organizations with thousands of developers and hundreds of use cases. So this is spinning up thousands of Kubernetes pods and PVCs. We added several features inside of the Coder product to help control and measure and ensure that these things aren't costing a lot. So one of them we added was autostop. And at a very basic level, this detects developer activity. So if the developer's inside their editor, it keeps the workspace on. When the user is no longer in their editor, it turns the workspace off. So we have a template level setting that can set an auto stop requirement. If the user is active, it can bump it by 3 hours, and you can also enforce updates. So that was one feature we added around cost savings. The disk itself still stays, but the pod is then shut down when the person's not using it. So you're not paying for compute that you're not using. So for folks who are already doing some form of cloud development, whether it's in virtual machines or in Kubernetes, again, these workspaces don't have to be running 24/7. They can just run only 8 hours a day or whenever the developer's using it for only 5 days a week. So there's significant cost savings there. The second thing that we support is a concept called bin packing. And this essentially allows you to over-provision your nodes. So with pods that have very small requests, but then can burst up to use more CPUs. So in this graphic I have here, if you add up the total amount of CPU the pod could actually burst to, it gets up to 56, even though the node only has 16 CPUs. However, because each pod is only limited to going to 8 CPUs total, when a build occurs, there's still plenty of resources available on the node. So unlike other Kubernetes workloads, when a developer is writing on their workspace, it's relatively bursty. So most of the time you can imagine their CPU is more at this level. And then when they need to run a build, it can burst up and use the rest of the resources on the node. A third feature we added in Coder to try to help with cost savings, if you can't kind of tell, there's a theme here, is a feature called quotas, which is Coder's a self-service platform. People can go in and request these workspaces. It provisions infrastructure, but at a certain point, you probably want to limit how many of these workspaces someone can create. So we added the quotas feature to limit specific groups in Coder, perhaps like contractors, to only being able to create maybe 1 or 2 of these machines, or it even gets a little bit more complicated where you can calculate how much a specific resource costs. So you can do some basic math inside the template to charge a certain amount of credits per disk, for example. So that was one of the third features we added around cost. And we're getting questions from our customers who are running these thousands of workspaces on how to control costs. So one question we would get is, what are the proper sizes for workspaces? Another question is, what are the proper sizes for nodes inside Coder? And the third is, what are the proper resource costs? So what should we actually be giving developers access to? You can kind of let developers select CPU, but there has to be some lower bound and there has to be some upper bound for a workspace. And then finally is, what's a good quota for developers? And keep in mind, in many cases, our customers are central platform teams who don't necessarily understand the day-to-day activities of the end user, the developer. So it may be difficult to monitor and understand the kind of workloads that are going to be run against Coder. So fortunately, there's a great application out there called Kubecost, which answers all of these questions. So I'm relatively new to Kubecost, so I'm going to be leaning on Jesse a lot here in terms of kind of the intricacies of the platform. But over the last 2 months or so, as we've been working on this partnership, it's become extremely obvious why a tool like this exists. And in Coder's case, we can use it to measure cost by Coder-specific properties, such as user, the language they're developing in, their template, their business unit, and even additional properties. So to really demonstrate this, about 2 weeks ago, I spun up an EKS cluster and created a simulation of a Coder deployment. This is very similar to how a lot of our customers have Coder deployed, but at a significantly smaller scale. The way this simulation works is every morning, 32 users will start their workspaces, or there's some kind of percentage chance that it will actually create a new workspace as well. Maybe they're spinning up a new project that day. And it picks oftentimes just the default amount of CPU and memory, but then sometimes it'll pick a very high amount or sometimes a very low amount. Essentially, it's kind of trying to simulate what a developer would be doing in. I know if I was in a coder environment, I would pick the largest CPU possible. I mean, why wouldn't I, right? I want as many resources, and I don't want my workspace to shut down. So we've been running this scenario for about 2 weeks now. A little bit about the cluster that I've been running it on. I chose EKS. I have 2 different node groups. I have one for services and one for workspaces. The services node group is just one instance, and the workspaces node group has auto scaling, and it actually can scale down to 0. So I did want to have a relatively cost-efficient experiment. You'll see there's still plenty of inefficiencies here, but I do have it scaling down to 0 in the weekend, so I didn't get a ping from someone and are asking, what's this going on here? Why are these nodes always running? But even with that, when I installed Kubecost, and to this day, it still reports that the cluster's only at 35% efficiency. So I kind of wanted to walk you through my story, kind of going through Kubecost, and Jesse or anyone in like the Q&A, feel free to ask questions as we go along, and we can kind of dive deeper into these things.
I mean, I guess maybe not a question, but just a comment, and how much I love like the self-service of Coder. And not only does it empower developers to get right on the projects they need to work on, but because our environments have been predefined, all these labels that to get the best benefit out of a tool like Kubecost to understand where costs are going, it requires some metadata, right? Whether that's the namespace, which is the default thing that's just inherently part of Kubernetes. Coder's able to put in metadata like, oh, it's for project XYZ. And so when we deliver this, we know what the infrastructure costs and the development time was for a particular new solution that you're bringing to market. And I don't know, I mean, this is a fantastic alignment of our tools. So I'll let you talk about how that's all defined here.
Yeah, totally. So I think it actually, to your point on the self-service model, this would be a good opportunity for me to just show the coder interface real quick and what that looks like from the user's perspective. I showed 2 different screenshots, but I'm here in the coder dashboard. The developer's perspective, they essentially can pick through several templates that are prepared for them. They can create a workspace. And this is a self-service model that Jesse was talking about here, so that the user can pick their CPU, their language, and their memory. Now, the memory and CPU go directly to the Kubernetes API. Those are things that Kubecost is very well aware of, but this is actually being sent as a label, so that we can kind of segment the usage by language. So going back into the presentation here, and I think there's a way for me to. Wondering if there's a way for me to do this full screen. Do this. Sorry, folks. Just want to have a good view here. And then I'll make this full screen. Great. So yeah, this is the kind of the template code behind the scenes that's actually applying these labels. So by default, our templates will kind of put a label. This is provisioned by Coder. This is the name of the workspace. This is the owner. This is the username. But then templates that have parameters in it, which are asking for perhaps maybe the language or what image you're using or what team are you on. Those things can be sent directly to the Kubernetes API as labels for Kubecost. The next thing that I found really valuable in Kubecost was the reports feature. This essentially lets you break down the usage even more. So I created 2 reports to understand the code deployment. The first one I did was cost by language, and the second was cost by user. The cost by user one, I think, is most helpful to identify power users or to identify bad actors, maybe people who are taking up way too much CPU for what they need, or maybe running some type of application on Coder that wasn't necessarily designed for. So going back into the Kubecost interface, I have these 2 reports up, and I'll make my screen a little bigger. The cost by language one was pretty nice. I just use the label aggregator here, and it gives me a really nice overview of what are some of the highest kind of cost language use cases in Coder. It shows me the CPU cost, the GPU, and it also kind of compares it to the previous date range, which I found super interesting as well. Something else you can do, which I found nice, is if I just click into Python, it actually shows me all the different workspaces. And the way Coder by default kind of labels the workspace, it's the username, then the workspace name. But here you can identify as well if a workspace is also being under provisioned and maybe needs more resources. And that's a pretty good opportunity to actually kind of help give people a better developer experience if they're running into issues. But more often than not, you'll see the efficiency. I guess on this, which one am I doing? On Python, the efficiency is actually quite good of these workspaces overall. Sometimes it's about 118%, which is quite good actually, given the requests and limits that we have set here. The other report I have is cost by user. I can show that as well. And again, it's just kind of filtering by that user label. Here I think something in my experiment went astray, and I realized I needed to get it down a little bit, but still wanted a nice demo. But you can see it's all relatively reasonable results here. But if there was some bad actor, I suppose you could see I did I was doing some pretty intensive activities in my workspace, or I requested a lot of CPU. That could be measured there as well. And if you click in, it'll show you all of the different workspaces that I have.
The other aspect of that graph there is just like anomaly detection, which Kubecost has a new feature for anomaly detection in terms of just calling it out specifically. But I will just give an example of a customer story I had where they enabled this logging service in the cloud provider, and the logs were significantly larger than they were, the costs were significantly larger than they expected. And so they just saw this like ramp of costs going on, and we're able to, get ahead of it as opposed to waiting for whatever the next time someone looks at the bill. So, I think it's good to see, the resources are being used efficiently, but then you also see the like spikes that you might want to get on top of quickly.
Yeah, it's a really great point. The third report that I put here, and I know this is top of mind for folks who really care about things like chargeback. Maybe you're running a deployment and you have multiple kind of groups using it, is being able to measure that cost, not per user, per group. Right now, that's somewhat supported in that you can create labels by template, or you can create labels by the parameters that people enter. But something we'll be adding into the Coder product to make this reporting better is actually exposing the group data in Terraform, so that can be labeled as well. So that'll be in a future Coder release. I see a question. Can you filter costs by workspace templates? We have multiple teams. Each team has a specific workspace template, and they need to assign cost accordingly. Yes, you can. So going back into the Coder dashboard, in the template code, you can set any of the labels that you want here. So in this case, because I know the template name is the standard workspace, I can add the label here and pass it in. Something that we could do is in our example templates also just pass in the template so that you kind of get the out of the box reporting, but you can add any labels that you need to a given template to then pass it into Kubecost. So yes, that's possible. Great. Another relatively cool feature that I found in Kubecost, as well as a quick win, was the savings insights page. The two things that I found particularly valuable here was recommendations around node sizing. I actually followed one of those recommendations and reduced my cost quite a bit maybe about a week ago. So if we went there now, we'd be in good shape. But the container request one is one that I really wanted to show. And in this case, we really want Coder workspaces to request a very small amount of memory and CPU, and then be able to burst up to use the rest on the node. But we don't want to request an excessive amount of resources if at most times the workspace is under that. So going back into the savings dashboard, I think I have it up here. I have the container right size saving recommendations. And even for these node-based workspaces specifically, I found this use case like particularly interesting. The way I had the simulation working, by the way, was different programming languages would essentially simulate different levels of load when the people are like either idling or building. And you can see here that the average node developer is requesting on Kubernetes 16 gigabytes of memory. And this is far from the amount that's actually being used. And when Jesse and I were going over this data, you were saying I was quite kind of shocked by this, but you were saying this is quite a normal occurrence inside with your customers.
It's very common. Like, and I mean, I think that it's over provisioning happens for good reasons. I mean, we want developers to be productive. Developers are expensive resources. I mean, it's why our tools are, you know, a good portion of the reason why your tool exists, and you know, we can help get those costs in line by just giving visibility into what that behavior costs. You know, I think anyone that's using Coder is going to have a little bit more mature environment management than, you know, like we do at Kubecost, where everyone has their own cluster. But that's just the nature of developing Kubernetes software. But I will just talk about savings for a moment. You know, if I've got all these containers that are using or requesting more memory and CPU than they're using, that's a reservation for resources within a VM, right? Just to take Kubernetes out of the picture here. And so if I've got 64 gig of memory on my VM and everyone's requesting 16, you know, you have a very finite number of users you can get on that particular node, which is what a VM is in Kubernetes. And so, you know, just reducing your requests doesn't reduce cost. But what does reduce costs is figuring out the correct reservation and then reducing your node count, because you don't have all this reserve capacity that no one is using or able to share, right? And so, and I look at memory and CPU very differently. Just while we're here, I mentioned this to Ben the other day, but you know, memory is not shareable. And so when Kubecost gives recommendations, our default recommendation is 20% more than that container has ever used in the history of the query that you're running. So if you're running a 2-day query and, you know, Ben's environment took 3 gigabytes for 5 minutes on, I don't know what's today, on Thursday, and then Kubecost will recommend 20% more than that. So it's still padding so that we don't get out of memory killed containers. And you're still save money by implementing the recommendation. On the flip side of that, CPU, right? And so the CPU is shareable. You know, I'm gonna have a job that runs for, I don't know, 45 seconds, uses 3 CPUs, but then it doesn't do anything because it's just waiting for the next request. And so you could have lots and lots of shared CPUs on a node, especially for a development environment. You know, when you're talking about production workloads that are going to serve end user experiences, then you start to be more concerned about CPU sharing. But you know, the customize button, Ben, if you don't mind clicking it, this is where, you know, in Kubecost, it allows you to define that workload profile. And so if it's a user-facing experience application, I'm probably going to click the high availability profile. And if it's a development environment where, you know, I want to save as much money as possible because we want to increase the earnings per share, then you can choose that. And obviously you can customize that within your needs as well. So I'll stop on my soapbox on resources, but hopefully that gives some idea of how I think about saving money.
Yeah, that makes a ton of sense as well. Our general recommendation has been to significantly to be significantly more protective over memory as opposed to CPU. Cool. So the next thing that I kind of wanted to share is now that we have this data, what can we do about it? So the first thing I would do in this kind of more slimmed down use case is instead of letting the developer kind of opt into the CPU and memory of their workspace, of course we can adjust the limits and requests to give to kind of slim down, but what I'm essentially like proposing is just give the developers the selector for the use case. And because we have like a good understanding and measurements in place to understand cost, we'll be able to provision the proper resources for those use cases. In some ways, it's a win-win for the end user. They don't have to necessarily think about, well, I don't know how much is this going to take? Let me try it on my local machine and then create this workspace, which is a significantly different like CPU. They can essentially just pick the language, get into Coder, and it gives both the developer and the operator confidence that things are running smoothly. Just as a bonus, I wanted to give a shout out to the Kubecost API. I spent some time playing around with this, and you can get really interesting metrics from the API that and kind of do what you need with it that you might not be able to in the dashboard. So this query that I'm showing here is actually just a query for a specific workspace. And we were talking about requests and limits. It's actually giving me the recommended requests that I should set and the requested memory as well. And it also calculates the amount of like savings you would get from this as well. The savings, I think, is, I mean, maybe Jesse, you could talk to me a little bit more. Again, the savings is really about being able to fit more things onto nodes, because what you're paying for here is the virtual machines or the nodes itself, not necessarily the containers itself. But I think because Kubecost has this excellent visualization of cost and node cost, that you'll be able to see after running this experiment for only a few days, kind of like that example I had before, how like drastically your cost can change over time, especially with in kind of these more I wouldn't call it low risk because these are developers, and developers like expect a very like good experience, but they're not customer facing applications. So there's some room to experiment with what's a good ratio here, and how can we kind of give developers the same amount of CPU they can burst to, or the same amount of memory they could burst to. I think memory is a better example, as Jesse was pointing out, while still kind of being conservative with the requests.
Yeah, I mean, I guess talk about a just general customer story again. So in Kubernetes, there's tools that are for security purposes, and they're like sidecars that attach to every single pod within your cluster. I had a customer that had a sidecar that had a CPU request that was like 4 CPUs per sidecar. And well, I mean, it was whatever it was something ridiculous. And as soon as they fired up Kubecost, they saw the cost of that security tool, and that it wasn't using those resources. So I was like, okay, use a tool, but let's get the request in line with what's actually happening here. And it was just an instant ROI for Kubecost, which we can talk about Kubecost free model in a minute. I mean, what Ben's using here is all Kubecost free. So, you know, we really want people to use our solution. This API you can pull into any of your dashboards. It's fantastic. You know, if you're a developer, you know, there's all kinds of information you can get and, you know, get value out of it.
Yeah, totally. And I really saw it just by adding these labels in, hooking up Kubecost, and everything I demoed on the coder side too is open source as well. The groups thing, groups is an enterprise feature, so when we support the groups labeling, that'll be paid. But being able to expose these labels into Kubecost is free. We think it's important that you understand how the coder deployment's working before or if you were to pay at all. And I got a lot of value from just setting up the labels, going into the Kubecost dashboard, and creating these 2 reports, frankly, just to understand a lot better how these requests actually kind of translate into what's being used. With that being said, I have started on a Kubecost module for Coder, which essentially will be able to expose some of this Kubecost data inside the Coder interface itself. I think it's, again, important to start by just making sure the labels are right. That's really where you get the most value and those like first tunings. But what this module does is adds the efficiency metric that's calculated into the Coder dashboard as agent metadata. So essentially, this is querying directly the Kubecost API and displaying it here, as well as a link into Kubecost to then see the cost of that given workspace. This is coming soon. It's work in progress. I'm not going to I can do a demo of the module itself. I don't want to do a demo of the code today. It's not in great shape. But the fourth bullet point here is something that I'm also super interested in exploring with Coder. So I think what we'd love to do is just find like a mutual like Coder and Kubecost user to validate this. But I think it could be really interesting to calculate quotas, which is one of our features for limiting like how many workspaces can be created or what resource can be used. And instead of the Coder users having to set an arbitrary kind of credit value for each workspace, using the Kubecost API to then inform those quotas, essentially so that you don't have to come up with your own currency. You can just say, I don't want this group spending more than this amount, and I trust Kubecost's numbers here, because that's what Kubecost does. So that these three will be coming soon, and this fourth one I put maybe, so we'll see. With that, I think we have some time for Q&A.
Yeah, I can kind of tee up here, Ben. I'll take one question, give you a chance to have a cup of water. But maybe when I'm done with this one question, you can talk about what your take on the future of Kubernetes is. That was a broad one that I thought was fun. I have my opinion, but I want to hear yours first. The one I'll take first is calculating, how does Kubecost calculate idle costs for a cluster and a node? That's a really good question. We actually had a talk about cluster efficiency at KubeCon last year. It's available on YouTube if you look for Kubecost cluster overhead, I think is the title of it. It's actually something that we do today. Obviously, you need to know what sort of resources are used within a node and within a cluster in order to give any sort of indication of where you could start saving money. But the interesting thing that we're developing is a UI that shows the overhead a node has that you can't use. And so a lot of shops are like, oh, I just want a small VM that's cheap per month. And they'll just run a lot of them so that they don't have too many eggs in one basket if something were to happen to that node. The downside to that is that a significant amount of overhead for just running base services on a node. And we've calculated this and we know what that costs. And so general rule of thumb is the bigger the node, the more efficient it is. Really shouldn't be surprised there. I use Kubernetes all day, every day, and it's really rare to have a node failure. So I don't have as much concern there. Maybe it's because all my use cases are developers here at Kubecost. So yeah, generally the math there, it's part of the API, but you just add up all of the container CPU and memory requests or their usage, subtract that from the amount of capacity available in the node or the cluster, and you get our idle cost. And that's highlighted usually at the top of every Kubecost graph because it's usually the most expensive thing in that environment. And so that's what we can help customers get better at. So I don't know, Ben, I'll kick it over to you on your vision of Kubernetes in the future.
Yeah, it's a very ambiguous question. I might change the question a bit to like what's the future of Kubernetes for the average developer, because that's kind of where we spend a lot of time thinking as opposed to like running cloud infrastructure at scale. And I from what I've seen, I don't think the average developer will be interfacing with Kubernetes. I think there's some really cool and important use cases for developers being able to have direct access to a cluster. I think Kubecost is one where it's extremely important that your dev environments are full Kubernetes clusters where anyone can do a kubectl apply or get pods and really just understand what's going on to kind of poke around. And I think that kind of scenario is also very important in like break class troubleshooting. So people can really understand and monitor it. But I think there's and I think like the term here is like platform engineering, internal developer platform. Coder in some ways is one, specifically for the IDE environment. But I think that the average developer will be able to kind of give a language or a service and give it to this kind of middle layer, which then can then translate it into Kubernetes and still give developers tools to view logs, understand if the CPU is too high, memory is too low, things like that. But I mean that's kind of where I see it going. I've seen a lot of things on social media about Kubernetes didn't live up to the hype, and I don't really know what that means. I think Kubernetes is extremely important. And I don't know, maybe I've just been reading the headlines, but I'm really curious where you're going with this as well, Jesse.
Oh, I mean, I worked at Nginx previous to Kubecost, so like you could think I'm biased because I work at a company that's built its whole business on Kubernetes. But even when I was at Nginx, and there was a good number of Nginx users that were replacing F5 hardware with servers that run Nginx, right? So it wasn't just a purely Kubernetes world. But even then, I said, if you're not developing your future application on Kubernetes, you're stuck in yesterday. And maybe that's a little bit aggressive, but having used Kubernetes, as much as I have, I don't see a reason for physical hardware. I see some need for on-prem. I will say I follow the articles that the CIO that had outsourced everything to the cloud and is bringing it back in. And not only are their costs lower, but their applications are faster. I believe that 100%. Just the nature of the latency of, having your application co-located with your, solid state NetApp array.
Yeah.
My brother works at NetApp. So yeah, that's kind of, I see some movement back to on-prem, but I don't see movement away from Kubernetes.
I see. Yeah, that's very interesting. I see some other questions here that were like submitted in advance. One says, we're already using Kubecost with Coder and want to know how to aggregate workspaces to projects cost. I think the demo that I showed per project was kind of on that language selector, where I kind of used language as an encompassing like definition of what the person's going to be working on, and some kind of understanding of the load. I think a more common and perhaps a more interesting one would be a lot of Coder templates ask developers, what Git repository do you want to kind of get started with? And what Coder will do is it'll take that Git repository and look if there's like a dev container file in it, or it may just auto clone it. It's really up to what you put in the template, but that's also data that the Coder kind of interface is aware of, and it can pass that on to Kubecost as well. So you could perhaps see usage by Git repository, and I think that's in many ways a better way to measure how much load like a specific kind of use cases, because if a developer 1 is running a build on a Git repository, it's probably very similar to what developer 2 is doing. Whereas some developers could be doing very high performance Java applications while others are doing something entirely different. So I think Git repository would also be a great way to segment it. And I think groups is the third one that I'm super interested in, is just separating it by like business unit or kind of template.
Yeah, awesome. I guess I'll take the one on, how accurate are costs. And to that is a little bit of depends on how you configure it. The basic installation, if you just Helm install Kubecost on your cluster, assuming it's in a cloud provider, we will detect the node type that the node types in that cluster and query that against the cloud provider API for on-demand pricing. And so if your costs are close to the cloud provider on-demand pricing, you don't need to do anything. Costs will be pretty accurate. That said, many of our customers are extremely large and they have very big discounts with the cloud provider. And for them, or for any user that wants to go through the effort, You can provide access to the cloud billing, so Kubecost can look up the actual billing of a node or all the resources, whether that's network, egress, storage, all the costs that go into Kubernetes. And we actually reconcile the actual price paid versus what was estimated with on-demand costs prior to the bill being available. And we're actually Kubecost 2.0 estimating based on previous discounts what your future prices will be. So there's some prediction built into Kubecost now as well. So yeah, it's 100% accurate. I would say penny accurate for a lot of our customers that do the billing integration, and then for those that don't, it's still giving you useful information, right? You might know that I get a 20% discount from GCP on average, so you could just say our kube cost display then be 20% inflated, but at least you'll still know what product is causing the most costs within Kubernetes, or which team is most efficiently using their resources. And so even without the billing integration, you get quite a bit of value.
Yeah, that's a good maybe point, like to bring up collections. I'll be able to speak very little to this, and maybe you can take over. But I have a quite simple cluster here, so really the only main workload I have running on here is Coder. I think I have Grafana, so it could have been interesting to compare how is Coder costing to Grafana as well. This is essentially just showing kind of all of Coder's cost, and I have the very simple deployment where I just Helm installed. I didn't set up a cloud integration. I think that would have given me significantly more important or more like accurate data. But to Jesse's point, I can still see, oh, it was costing a lot and now it's a lot less, and it's by this percentage. And even that's like a good progress, right? But I think collections as well would show the kind of, if costs were coming in from another center as well, such as like AWS, for example, it would show and add, or it'd be able to deduplicate that data. Is that correct?
Exactly. I mean, the collections is like our second iteration, depending on how many, where you start counting, of how you can combine your Kubernetes costs with some cloud native service. And so if you're using S3 to back your application, you can associate those costs to the namespace or whatever the label is that you're using to break down your costs. And so collection does that. And a lot of our focus on collections we just released our 2.0 version this year, since January. And we're trying to get it more performant and then more granular where we can. I guess the one, I'll bring it up because I often get this, is, well, can I break down my costs in the S3 bucket? And the answer is, if you can tag it, we can marry it up to your resources in Kubernetes. If you can't tag it, then there's no way for us to get it today. We're obviously looking at as much as we can do to divide up the things as much as we can, but ultimately we're a little bit at the whim or the mercy of the cloud provider's granularity. And then there's a couple other questions, but if there's anything that we haven't addressed, please let us know in the Q&A. Anything else that you wanted to answer, Ben? I don't know if you're looking at the Q&A advanced questions. Real use cases for productivity gains for customer use cases that you've run across?
Oh, yeah, with Coder. Yeah, I mean, I can talk about both cost savings and productivity. I think the main productivity one that we see calculated is, and in each kind of organization should do their own kind of gather their own data and do their own experiments. But essentially they calculated the amount of time that Coder saves a developer per week. And it was roughly, I believe, like 10 hours or something like that. And then you just kind of multiply that by like the developer, or you kind of calculate that with the developer's like salary. So I think that's like a real use case. We have several case studies published on our website that we do with customers as well that have been like pretty interesting. And I guess onto the cost savings one. We've seen a lot of our users already kind of running these cloud developer environments using either a homegrown tool or people are creating infrastructure themselves. The main cost saving just with Coder alone is that these workspaces aren't running 24/7. They're really only running like 8 hours a day or whenever the developer needs them. So that's kind of the main cost saving there. And I think we have a case study with Skydio where I think they saved roughly like 90% of their cost doing that, as well as some of the over provisioning things we were talking about earlier.
We just got a question on the Kubecost certification program. I not an expert in that. I will say it is focused on FinOps and not how to install and configure Kubecost. Installing and configuring it's a one-time deal. I've got customers that run very old versions of Kubecost that work just fine, and so it tends not to be a thing you need to maintain a lot. Obviously, there's new features, new performance improvements, and new versions. If you benefit from them, absolutely upgrade. But I had a user this morning ask why we changed the API from a version of Kubecost we had in 2021. So I think that says a lot for how useful Kubecost has been to them, and that it didn't go obsolete. So yeah, I don't know if Morgan is still here and he wants to ping me with a link or something like that to our certification, we'll share it. But yeah, it's we have a lot of our early or the people that bring Kubecost into your organizations tend to be DevOps because it's an easy Helm install that you can put in your environment. But the end user is some typically a FinOps type person that's trying to understand the cost per product or the cost per customer, so that they can do potentially show back or charge back, having the data in front of them. So that's a little bit more on who uses Kubecost. And I don't know if there's anything else, but I will share that we have an email address for our certification. If you email that, they'll happily send you better information than what I just shared. So sorry about that.
Cool. Yeah, well, with that, I think I don't see any more questions, so I think we're good to end it. But yeah, if you're interested in these use cases, if you're using Coder and Kubecost together, we want to hear from you. So I'm sure there'll be follow-ups sent as part through this webinar where you can get in contact with us and we can work together.